Hi everyone, welcome to Math World. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 5, which is the Probability and Statistics 1 for May-June 2023, and the code is 9709/51. Okay, so let's move on to question number 1. A summary of 50 values of x gives summation x minus q equals to 700, and summation of squared for the x minus q is 14235, where q is a constant. Now A, find the standard deviation of these values of x. Alright, so the n is 500, n is 50. Okay, summation x minus q is 700. And then summation of the x minus q squared equals to 14235. Now, you are given x minus q, summation of x minus q. So I may use the coding method, alright? So let y equals to x minus q, which means summation y equals to 700, and then summation y squared is 14235. Okay, so now instead of getting the standard deviation of x, I can find the standard deviation of y first. So now standard deviation of y, which is the sy, is going to be some square root of summation y squared over n minus y bar squared. Okay, so now it becomes square root of summation y squared is 14235 over the n is 50. Then y bar is summation y over n. Okay, so it will be 700 divided by 50, and then you square it. So from here, you will be getting 9.42. Now, basically, standard deviation of x, which is sx, it will be same as xy. So, which is 9.42. Okay, so that's all for the first part of this question. Now B, given that summation x is 2865, find the value of q. So now I'm going to use summation x minus q equals to 700. Now this means since you have 50 values of x, you see 50 values of x, means that this summation x minus q means you are summing, or you are getting the total of each x for 50 times, because you have 50x here. Okay, which means this summation x minus q is basically same as summation x minus summation q equals to 700. So this summation x is 2865. Summation q means that you get the sum of the q for 50 times, because our n equals to 50. Okay, which means this is 50 minus 50q. Okay, summation q is basically 50q. Alright, because you add this x minus q for 50 times, because there are 50x. So equals to 700. So from here, I know that 50q is 2865 minus 700, which is 2165. Then your q is going to be 43.3. Okay, you can just write 2165 divided by 50. And then at last you are getting 43.3. That's the q value. Okay. Question 2. A. Find the number of ways in which a committee of 6 people can be chosen from 6 men and 8 women if it must include 3 men and 3 women. Okay, so now from here basically you have 6m, 8w. Then from here you have to choose 6 person. Each gender consists of 3 person. So obviously this is combinations. So number of ways will be 6c3 times 8c3. So 6c3 is 20, 8c3 is 56. Therefore, you will be getting 1120. Right? Now B, a different committee of 6 people is to be chosen from the same combination, 6 men, 8 women, and 3 of the men are brothers. So here 3 brothers, and then another 3 not in any relationship. B, find the number of ways in which this committee must be chosen if there are no restrictions. Okay, again you choose 6. So from here you choose 6. So if there are no restrictions on the number of men and women, but it must include not more than 2 of the brothers. Okay, so when not more than 2 of the brothers means that maximum is 2. Okay, maximum 2 brothers. Right? So now maximum 2 brothers. So for this question we have 2 methods to solve. So the first method is direct. Consider maximum 2 brothers. So now I will say that it can be 2 brothers, and then since I need 6 person, then I have to choose another 4. Okay, and then it could be 1 brother, then I have to choose 5. Then it can be just none of them, so I have to choose any 6. Alright, so now just for your information, if 2 brothers are chosen, that means another 4 person here, the remaining committee members must be chosen from these 2 combinations. Means 8 women plus another 3 men. So total here will be 11. Alright, so from 11 I need to choose 4. So it means that for the first one is going to be 8C4. Now this is number of ways, so I will write number of ways equals to 8C4. Okay, and at the same time I have to choose the 2 brothers. So 2 brothers means that there are 3, then you choose 2. Or is plus, right? I need 5 person from this 11. So 11, choose 5. And then I choose 1 brother. So 3, I choose 1. Okay? Or I choose 6, any 6 from this 11 person. So 11, C6. Okay? So the first value is going to be 990. Second is 1386. And then the last one is 462. So at last, you will be getting 2838. This is by direct considering maximum of 2 brothers. Also the 6 person. So if you don't want to use this method, I have another method to be used, which is, now we know that there will be maximum of 3 brothers. Okay, now you need to find maximum, there will be 3 brothers. You need to find maximum 2 brothers. Means that when you consider the brother itself, it can be none of them. It can be 1, 2, or 3 chosen. Okay, so the question is saying that not more than 2 means that maximum is 2, which means you are considering 0, 1, 2. As I have shown here, I'm considering 0B, 1B, and 2B. So if you don't want to use these 3 methods, consider these 3 cases, you can just use a complementation rule, which means you use any selection minus 3 brothers are selected. Okay, that is the alternative method. So you can say alternative method, which is number of ways equals to number of selections without restrictions minus number of selections when 3 brothers are selected. Okay, so when you minus when 3 brothers are selected means that you minus 3, which means you are finding 0, 1, 2. So now for number of selections without restrictions, basically you just consider in general. So in general, 6 plus 8, it will be 14. Out of 14, I need to choose 4 person. So which means it will be 14, out of 14, okay, out of 14, 6 plus 8 is 14. I need to choose 6 person, not 4. Okay, I need to choose 6 person. Therefore, it will be 16C6. Sorry, it will be 14C6. Then minus when the 3 brothers are selected. Okay, so when 3 brothers are selected, which means I need to choose another 3 person from this 11 person. Okay, so since 3 brothers are selected, so 3C3, and from 11 I need to choose another 3 person. Okay, so here it will be 3003 minus 165 because 3C3 is 1. Therefore, you will be getting 2838. So it is the same answer if you use a first method. Okay, so these are the 2 methods to solve this question. Now, for question 3, find the number of different arrangements. So arrangements of the 8 letters in the word COONED. Alright, so COONED. Alright, so from here, there are 8 letters. Out of 8 letters, I have 2C. Then I have 1, 2, 3, 3 O's. And then I have NED. Okay, so these are the 8 letters. And then the question, just very general, find the number of arrangements. So number of arrangements. Since we are arranging all 8 letters, so the working is 8 factorial. But out of 8 letters, there are 2 C's, so 2 factorial in the denominator and 3 factorial for the O. Okay, therefore, you will be getting 3360. Now B, find the number of different arrangements if 8 letters in the word, okay, same word, in which the first letter is O and the last letter is N. Right, remember just now we have 8 letters, 2 C, 3 O's. Okay, then you have NED. So now it's mentioned the first is O, then the last is N. So since we have total of 8 letters, means that in between we have 6 letters. Out of these 6 letters, you still have 1 O. Okay, sorry, you have 2 O's because initially you have 3 O's. So 1 O is taken here. So you have 2 O's and 2 C. Okay, then of course you have NED here. Sorry, you have ED. Okay, here you have E and D. The N is taken, which is the last place. Alright, so now the O and N already fixed, so it means that we do not need to arrange them anymore. What to do is we just need to arrange the middle 6 letters. So number of arrangements. Since we are arranging all 6 letters, 6 factorial, but there are 2 O's and 2 C's. So you just need to divide by the factorial. And at last, the number of arrangements will be 180. Okay, so now see, find the probability that a randomly chosen arrangement in 8 letters of the word has all 3 O's together, given that, so the keyword, given that means conditional probability, the 2 C's are next to each other. Okay, so I will write down, this is P, 3 O's together, so 3 O's, given that 2 C's. So from the conditional probability formula, PA slash B, it will be PA intersect B over PB. Okay, so from here I will get P, 3 O's intersect 2C over P, 2C's. Okay, so what does it mean by 3 O's and 2C? So these 3 O's together, intersect means N, 2 C's are next to each other. Okay, so now my diagram, or probably I just draw this, 3 O's together means I put them in a group, and then 2 C's are next to each other, that means I put them in a group as well. So remember, at first you have 8 letters. So now we have considered 5. That means you still have 3 more left. Okay, which are the NED. So now, in the questions, it doesn't mention that it must be starting with the O and then followed by the C. Means that it can be in any order. Now, I have to arrange all together of 5 letters because when I group the 3 O's in a group, right, put them in together, that means they will be treated as one letter. Then the 2 C's, to make sure that they are next to each other, then I will put them in a group as well. So I treat this as one letter. So total of 5 letters, right? So now I need to arrange all these 5. That is my intersection probability. So it will be 5 factorial. Now, probability is n how many elements of this over the ns, but I know that for this, for the denominator also have to divide by the ns, so I will just ignore the ns, right? So then over my P2C. Okay, P2C means that now just 2C are together, okay, are next to each other, then no other restrictions. Means that now instead of 8 letters here, I have considered 2C, means that I still have 6 more letters here. But out of these 6 letters, okay, don't forget you have 3 O's. Okay, 3 O's. Then now, and again in the question doesn't mention that the C must be the first place, which means now this 6 plus the C becomes 7. Okay, here 1, here plus 6, it becomes 7. So it means that I need to arrange all 7 letters. So when I arrange all 7 letters, it will be 7 factorial. That is for my P2C. Then don't forget, out of this 7 factorial, alright, you still have 3 O's. So you cannot just leave 7 factorial here. So you must divide by the repeating factor, repeating objects, which is the 3 factorial. This 3 factorial means the O. Alright, then at last you will be getting 120 over 840, and this can be simplified to 1 over 7. So this is how we solve this part C. Okay, now question 4. A mathematical puzzle is given to a large number of students. The times taken to complete the puzzle are normally distributed with mean 14.6 minutes and standard deviation 5.2 minutes. So now in a random sample of 250 of the students, how many would you expect to have taken more than 20 minutes to complete the puzzle? Okay, so first of all, I will write down the x is normally distributed, 14.6 minutes as the mean, and standard deviation 5.2. So variance becomes square of 5.2, which means now my x is the time taken to complete the puzzle. Okay, so now to solve this question, in order to get how many students, right, that satisfy this condition taken more than 20 minutes, I need to count their probability first. So probability of x is greater than 20 minutes. Alright, so P, standardize it, Z more than 20 minus 14.6 over 5.2. Then here, when you simplify, this is 1.038. So when PZ more than 1.038 or PZ more than 1.038, we draw the graph. This is the normal graph. And then the line is 1.038, which is on the right hand side. The region is more than, means that it's upper tail. Now, when you refer to the normal table, you are given the region towards the left hand side, okay? And the critical line is positive. So from here, it will be total probabilities 1 minus PZ or Z less than 1.038. That will be the shaded region. So which means my working is 1 minus PZ or Z less than 1.038. Okay, so now from the table, you will be getting 0.8504. Okay, that's the probability. Then After you minus from 1, it will be 0.1496. And then our working doesn't stop here because you are given 250 students. How many out of these 250 students will be taken more than 20 minutes? So this is the probability for one student. Okay, so now number of students will be 250 times 0.1496. Then you will be getting 37.4. And now, since this is number of students, right, that means I will say it's approximate to 37 students. So that's the solution for A. Now, all the students are given a second puzzle to complete. Their times in minutes are normally distributed with mean, mu, standard deviation, sigma. So now I will write x is, okay, I don't use x anymore because x is for the first puzzle. Now I use y. It is n, mu, variance, sigma squared. It is found that 20% of the students have times less than 14.5 minutes. So P, Y less than 14.5. It is 20%. So 20% you convert to decimal, it will be 0.2. And 67% of students have time greater than 18.5 minutes. So P, Y greater than 18.5, it will be 67%. That means the probability is 0.67. Okay, so now B, find the value of mu and sigma. So now, first of all, we need to standardize the y. So when I standardize the y, it becomes z less than 14.5 minus mu over sigma equals to 0.2. Okay, so I will solve the first probability at this moment, then followed by the second probability. So from here, I need to sketch a graph. Alright, so since this is less than, that means, and the probability is 0.2. Look at here. We have two possible results for this 14.5 minus mu over sigma, either on the left hand side or on the right hand side. But since this is less than, means towards the region will be towards the left hand side. Alright, or probably it is here. So obviously, now for your information, okay, when it is less than 0, the pz less than 0, it is 0.5 because it's half of the whole graph, area of the whole graph. So which means now the probability is only 0.2. Obviously, you should choose the first one. Okay, because if you choose the second line as your value here, 14.5 minus mu over sigma, that means the probability should be more than 0.5. Okay, so this is how we choose it. So which means now I need to redraw my diagram. Basically, I'm getting the region on the left hand side. And I will label this as 14.5 minus mu over sigma. And this is 0.2. Now, when you look at this graph, since the region is on the left hand side, okay, you are not able to get the value from the table, the normal table. What to do is we reflect. So once we reflected it, the region is still the same, 0.2, but then your value of this blue line is negative of the original line. Okay, so now when this upper region is 0.2, so I will write here P z more than negative of 14.5 minus mu over sigma is 0.2. But then the normal graph always given the region towards left hand side. So when right hand side is 0.2 means the left hand side is going to be 0.8. Okay, so now I will write here P z less than negative of 14.5 minus mu over sigma is going to be 0.8. So now from table, you can get the answer from table. Pz less than 0.842 is 0.8. Okay, now I will just compare. So negative of the whole bracket is going to be 0.842 because the rest are the same. So now negative of 14.5 minus mu over sigma is 0.842, and then I can get one equation. So negative 14.5, the minus you times into the numerator, then plus mu, the sigma move to the right side, equals to 0.842. This is my first equation that I've obtained from the first probability. Okay, so do the same for the second probability. So now we need to standardize the y. It becomes like more than 18.5 minus mu over sigma equals to 0.67. Once you get this, then quickly draw the graph. Okay, probably I'll draw here. So again, now when you look at here, it is more than a number when you more than 0, when the pz more than 0 is 0.5. Then now, more than the line, okay, because I'm not sure where is this line, it is 0.67, which means the line should be on the right, on the left hand side, because it will be greater than 0.5. Okay, so this is 18.5 minus mu over sigma. So when you look at this, I need to reflect my graph. So my graph now becomes on the right side, the line. So here is going to be 0.67 because here is 0.67, and then once I have reflected it to the right side, the value becomes negative. Okay, so from here I will write pz less than negative of 18.5 minus mu over sigma is 0.67 based on the graph. So since it is on the right hand side, then region is towards the left hand side. That means you can use the table. So I will write from table pz less than 0.44 will be 0.67. And then now use the same concept as just now. Just compare. Okay. Then you will be getting negative 18.5 minus mu over sigma is 0.44. Same concept as just now, times in the minus to the numerator. So I will get negative 18.5 plus mu, and then the sigma will be moved to the other side, equals to 0.44 sigma. This is my second equation. So now, to solve the mu and sigma, I just need to solve first and second equation. So when you check the left hand side of both equations, both are plus mu. Okay, then I can just use first equation minus second equation. So minus 14.5 minus 18.5, then the mu will be cancelled off. It will be 0.842. Okay, this is sigma. The sigma is missing because I moved the sigma to the right side. Then minus 0.842 sigma minus 0.44 sigma. Okay, so from here, the left hand side is 4. The right hand side is 0.402 sigma. So your sigma is 4 divided by 0.402. And my sigma is going to be 9.9502. Final answer, I leave it to 3 significant figures. So 9.95. Now I need the sigma to get the mu. That's why before I write down the final answer of sigma as 9.95, I write it as 9502. Okay, 9.9502, because I'm going to use this value 9.9502 for the next calculation. So now from first equation, my mu is going to be 0.842 sigma plus 14.5. Okay, just move this minus 14.5 to the right hand side. Then at last, you will be getting 22.9. Alright, so this is how we solve this question. Alright, question 5. The populations of 150 villages in the UK to the nearest 100 are summarized in the table. A. Draw a histogram to represent this information. So now, to draw the histogram, okay, just a revision. Histogram, the horizontal axis will be the class boundaries, and then the vertical axis sometimes frequency density. Okay, so it depends on your class width. So let's look at the class width first. 100 to 800, then 900 to 120, 1200. So obviously the width is not the same. Alright, so due to that reason, we need to use the frequency density. So this frequency density is frequency over class width. So now first is I get the class boundaries first. Okay, so class boundaries. Before I get the frequency density, I get the class boundaries first, because these two are the limits. Okay, so class boundaries will be counted by getting the average of the limits here. So 800 plus 900 divided by 2, it will be 850. Okay, so when you look at the next one, here is 840 and 850 until average of 1200 and 1300 is 1250. Okay, then here you just copy 1250. Average of 2000 and 2100 is 2050. Then here 2050 until average of 3200 and 3300 is 3250. So here 3250 until now. What do we get for the first upper boundary, first lower boundary, and then the last upper class boundaries? So you just look at here, 800, 900, there's a gap of 100. Then the next one, 1200 followed by 1300, again a gap of 100, which means I will expect the previous one is 0. Okay, so the average of 0 and 100 is 50. Alright, and then for the last class is the same concept. I will expect that the next one is going to be 4900. Then the average of these two values is 4850. Okay, so done for the class boundaries. And just now I have mentioned that the class width are not the same. So the class width is basically upper boundary minus lower boundary. Okay, so 850 minus 50, I will get 800. Then 1250 minus 850, it will be 400. So when you minus 2050 minus 1250 is 800. Then here you minus, it's going to be 1200. Then here you minus, the last one is going to be 1600. That all these are the class widths. Then lastly, it will be the frequency density. Alright, FD. This FD is F over C. So this is our F, number of villages. So 8 over 800, it will be 0.01. Then 12 over 400, 0.03. 50 over 500, 0.0625. 48 over 1200, 0.04. Lastly, 32 over 1600, you will get 0.02. Okay, so we need all this information before we start drawing the histogram. So now remember, our horizontal axis is class boundaries. Means that now I need to label 50 until 48550. Okay, so now look at the horizontal axis here. Right? So 1, 2, 3, 4, 5, 6. Okay, so now we need to consider our scale. So for the first class, right, the class width, look at here, the first class here, 50 to 850. The class width is 800. Then the next one is 400, 800, means that the class width are in the multiple of 400. Okay, so then I will start with 50. Multiple of 400. But then if we use 400, let's say here is 50, I start with 50. If the width is 400, here is 400. Then since this is just up to 6, I mean here you can just label another for another 6 values. So 6 times 400, it will be just 2400. But then we need to label up to 4850. So 400 is not enough. Therefore, I will choose to use 800. Okay, which means here is 800. That means I will label 850, then 1650, then 2450, after that 3250, and then 4050, and lastly 4850. Okay, because our lowest is 50 and the biggest is 4850. Then I will label this as class boundaries, or probably you can just write number of villages. Number of villages. Okay, then for the vertical axis, let's look at the frequency density. Lowest is 0.03, the maximum is 0.0625, the rest 0.02, 0.03. Oh, sorry, the lowest is 0.01. Okay, so now the easiest is I just let this be 0.01, then here 0.02, then here will be 0, then 0.03, 0.04, 0.05, 0.06, and then here is going to be 0.07. Then this will be frequency density. Okay, so now for the first class, 50 to 850, and then the frequency density is 0.01. So 50 to 850, 0.01, that means it's here. Alright, then the next one is 850 to 1250, the frequency density is 0.03. 1250, the width is 400. Okay, the width is 400. So since 10 squares will be 800, so 400 means 5 squares. Then the frequency density is 0.03. Okay, so when you draw, please use ruler. Okay, hang on please. Okay, there's the second bar. Then the third is 1250. The difference is the width is 800 and then 0.0625. Okay, 800 is up to here. 0.0625. This is 0.065. Okay, 625 means in the middle. So in the middle. Right, as I've mentioned just now, please use ruler to draw straight lines. Okay. Then the next one is 2050 to 3250. The difference is the width is 1200, the height is 0.04. So 1200, so it will be 40. Okay, is here. 0.04 is here. Right. And then lastly, it is up to 4850, and then the frequency density is 0.02. Okay, so this is the histogram. Right. B. Write down the class interval which contains the median for this information. Okay, so let's look at the total. Total is 150 villagers. So now median is half of 150 theta, which is theta number 75. Okay, so now for theta number 75, we need to know where is the what is the cumulative frequency, right? So I will write down this 8, 12, and so on first. So cumulative frequency, the first is 8. Now for your information, cumulative frequency is counted by adding the total with the previous total with the next value. So 8 plus 12, the next capital F is going to be 20. So here is 20. After 20, this total will be added with 50. So 20 plus 50 is going to be 70. After 70, okay, you plus with 48. So you will get 118. Lastly, 150. Okay, these are the cumulative frequency. Now, the theta, the median is the theta number 75. Okay, so which means it cannot be in the third class because the third class is just up to theta number 70. So the median is in the fourth class. Therefore, class interval, right, equals to fourth class. So the fourth class 1, 2, 3, 4, which is 2100 to 3200. Okay, that's the class interval that contains median. Now C, find the greatest possible value of the interquartile range for the populations of the 150 villages. So interquartile range is Q3 minus Q1. So now firstly we find Q1. Q1 is 1 over 4 of 150 theta, which is theta number 37.5. Okay, so 37.5, look at the capital F here, it will be in the third class because the second class is up to theta number 20. So the third class, okay, so since now you need to get the IQR, interquartile range, we do not refer to the class limits, but we will refer to the class boundaries. Okay, so the third class boundaries, so I will refer to 1250 to 2050. That will be my first class boundary. I mean first quarter class boundaries. Okay, so 1250 to 2050. So now same for the Q3. Q3 will be 75%, or I will say that it is 3/4. So 3/4 of 150 theta. So it's going to be 112.5 theta. So 112.5 theta is in the next class because next class is up to 118. So then I will write down Q3 class boundaries. It's the fourth class boundaries. The first one is 2050 to 3250. Okay, so now my greatest interquartile range is Q3 minus Q1. Okay, so from here, we do not get the actual Q1 and Q3. We just know the class boundaries for Q1 and Q3. But then in order to get the greatest interquartile range, I must take the biggest Q3 minus smallest Q1. Okay, so look at the Q3. Q3 is 2050 to 3250. Now, I cannot take 3250 because when you look at the class boundaries here, when you take exactly 3250, I can say that it is in the next class already, in the last class. Okay, but now I'm sure that the Q3 is in the fourth class. So I have to take slightly less than 3250, which is 3249. Okay, so here I will write 3249 minus the Q1. Q1 is 1250 to 2050. So from here, right, 1250 to 2050, I need to take the smallest. So I have to minus 1250, right, because 1250 will be in both. It can be in the second class or in the third class. So that's why I have to take minus 1250. So it will not be in the second class. Alright. So alright. So therefore from here you will be getting 1999. So that will be the greatest interquartile range. Okay, question number 6. Ellie has four four-sided dice, which sides labeled 1, 2, 3, 4. He throws all 4 dice at the same time. The random variable x denotes the number of tools obtained. Alright, so A, show that Px equals to 3 means that he is getting 3 times of number 2. Okay, equals to 3 over 64. Now, from here, you should understand that P1 is 1 over 4. Okay, P2 is 1 over 4. P3 is 1 over 4. P4 is 1 over 4. So now our constant is 2. So that means P2 is 1 over 4. If not 2, it will be the rest. Alright. So I will say that this is going to be binomial distribution, because when you throw 4 dice, okay, this is for 1 dice, right? P1 is 1 over 4, P2, P3, P4 equals to 1 over 4. This is for 1 dice. So now when you throw 4 dice, right, and then you'll be getting 3 times of number 2, which means this is binomial distribution. So I will say that my P equals to P2, which is 1 over 4, means that my Q is going to be 3 over 4. So my Q means not getting 2. And then my N is 4, because you are throwing 4 dice. So I will say X is binomial, 4 and 1 over 4. So the X here means how many times you get the 2 out of the 4 dice. So now we need to get Px equals to 3. Since this is binomial, just for information, when X is binomial distributed with NP, then probability of X equals to small x, it will be NCX, Px, Qn minus X. That's why I've written down the Q is 3 over 4 here. So now for this question, it will be 4C3, because your N is 4. You are throwing, he is throwing 4 dice. And then you are getting 3 successes. So the probability of success is 1 over 4, and there are 3 times, because all of them are independent events, right? Then the failure will be 1. So when you simplify this, it will be 3 over 64. Alright, so that's the solution for A. Now B, complete the following probability distribution table for X. Again, the X means how many times of getting 2. Okay, so now we need to count X equals to 1. So use back the same formula. X is binomial, N is 4, probability of success is 1 over 4. So when Px equals to 1, it will be 4C1, 1 over 4 to the power of 1, 3 over 4 to the power of 3. 3 failures. Then you will get 27 over 64. So here I will write 27 over 64. Then when Px equals to 2, it will be, okay, you can count by using the formula, or you can just use 1 minus the rest. Alright, so I will just write probably 4C2, 1 over 4 to the power of 2, 3 over 4 to the power of 2. So at last you'll be getting 27 over 128. So that's the solution for the part B. Now C, find Ex. So Ex is expected value of X, which is summation X times P. By referring to the previous probability distribution table, 0 times 81 over 256 can be ignored because it will be 0. Then plus 1 times the probabilities until the end. That is the calculation of Ex. So my working is going to be 1 times 27 over 64. Summation means plus. Then the next is 2 times 27 over 128. 2 times 27 over 128 plus 3 times, the next X is 3, probability is 3 over 64. Plus 4 times the last probability 1 over 256. Okay, so from here, you will be getting 1. Okay, that's the solution for expected x. Now, D. Ellie throws the 4 dice at the same time on 96 occasions. So now, you throw 96 times. Each time 4 dice. So use an approximation to find the probability that he obtains at least 2 times of 2. At least 2 twos on fewer than 20 of these occasions. Means that now I need to find what is the probability of getting at least 2 twos. So at least 2 twos means that it could be px. This is same as px greater equals to 2. This 2 is because of this 2 here. Alright. So it will be px equals to 2 plus px equals to 3 plus px equals to 4 because he's tossing 4 dice. So just add up all the probabilities. 27 over 128 plus 33 over 64 plus 1 over 256. Or you can just use 1 minus the previous 2 probabilities. Right? So here I will write it is 27 over 128 plus 3 over 64 plus 1 over 256. Then it will be 67 over 256, which means to get at least 2 twos, the probability will be 67 over 256. And now he is tossing, this is out of 4 dice, right? When he tossed 4 dice, the probability of getting at least 2 twos is this probability. And now he is tossing for 96 times, each time with 4 dice. And now you need to get probability that less than 20 times he will get this at least 2 twos. So which means now your n equals to 96. Your p is 67 over 256. Now I will get, this is binomial, but since your n is greater than 50, therefore we are going to approximate. So now get the NP first. So NP is 96 times 67 over 256, which is 25.125. Okay, then the NPQ is 25.125. That is our NP. Multiply with the Q. So your Q is 1 minus 67 over 256, which is 189 over 256. So here I will write 189 over 256. Then this is going to be 18.5493. Okay. So now since your NP is greater than 5, that means we are going to use normal approximation, which means your x at first binomial, n is 96, the p is 67 over 256. Now we will approximate to normal distribution with mean 25.125, variance is 18.5493. Okay, and now we need to count the probability that fewer than 20, so less than 20. So p x less than 20. Now, since your x is binomial and we approximate it to normal, binomial is discrete, normal is continuous, therefore compulsory to carry out the correction, the continuity correction. So less than 20, we mark 20 here, but the actual values will be 19, 18, and so on. Okay, so for the continuity correction, we are allowed to plus or minus 0.5 from the given x, which means it's either 20.5 or 19.5. And now we follow this symbol less than, which means I will write PW less than. So when less than means the region, it will be the values will be towards the left hand side. So obviously to include these two ticks, right, I have to choose 19.5. Okay, So then I will standardize it because your W is normally distributed. So when you standardize, it will be 19.5 minus 25.125 over, remember, this 18.5493 is the variance. We always divide by the standard deviation. So put the square root. Alright, then from here you will get PZ less than negative 1.306. And then we have to sketch a graph. The region is towards the left hand side. Now I reflect it to the right hand side. And then the region will be the upper region. So now the table always shows the region towards the left hand side, means that in order to get the region on the right hand side, it will be 1 minus the PZ less than 1.306. So I will write here, it is same as PZ more than 1.306, which is also same as 1 minus PZ less than 1.306. And then this 1.306, you can get it from the table. And then it will be 1 minus 0.9042. At last, it will be 0.0958. That is the probability of less than 20. Okay, so now question number 7. A children's wildlife magazine is published every Monday. For the next 12 weeks, it will include a model animal as a free gift. There are 5 different models: tiger, leopard, rhinoceros, elephant, and buffalo, each with the same probability of being included in the magazine. Now, Sahim buys 1 copy of the magazine every Monday. A. Find the probability that the first time that the free gift is an elephant is before the 6th Monday. Okay, so now elephant is considered as the success. First time to get this elephant means that this is the first success. So when first success, this is geometric distribution. Okay, then the probability is 1 over 5 because you have 5 different models, each with the same probability. That means the P equals to 1 over 5. Now, the probability of getting this first success is before 6 Monday. So Px less than 6, before 6. Alright, so for your information, if it is geometric distribution, right, x is geometric, Px less than equals to small x, it will be 1 minus q power x. So of course the q is the 1 minus p, right? Q is 1 minus p. Now, in order to use this formula, we need to change to less than equals to. So now you need to count Px less than 6. Px less than 6 is same as Px less equals to 5. If you remember this formula, then you can just direct apply. Then here I will get 1 minus, so your P is 1 over 5. That means your Q, okay, Q is going to be 4 over 5. Then I will write 4 over 5 to the power of 5. Then you will be getting 2010 over 3125. Or you can just leave your answer in decimal, which is 0.672. Correct to 3 significant figures. What if you have forgotten this formula? Alright, then don't worry, we still can count this probability using manual calculation, which means, okay, this is the second method. Now we need to count Px less than 6. Px less than 6, we know that it will be Px equals to 1, Px equals to 2, plus until 5. Okay, all these are px less than 6. Now px equals to 1 means that first Monday, he already obtained the elephant as the first as the free gift. Means that is the success, 1 over 5. Okay, when px equals to 2 means that second Monday, then only he gets the elephant. Means that first Monday he didn't get, so the probability is 4 over 5. Means that he obtained other model. Then second Monday he got it. Px equals to 3 means that first 2 Mondays, first and second Monday, he didn't get it. And then the third Monday, he got the elephant as the free gift. So px equals to 4 means the first 3 weeks, the first 3 Mondays, he didn't get it. That means the probability is 4 over 5 to the power 3. And then the fourth week, he got it. Okay, plus when px equals to 5 means that this is 4 over 5 to the power 4, and then 1 over 5 to the power 1. So when you count all of this, you will be getting the same answer. Okay, so this is manual calculation. In case you have forgotten this formula, px less equals to x is 1 minus qx. Then you have to manual calculate to consider 1 by 1. So that's the solution for this A. Now B, find the probability that Sahim will get more than 2 leopards in the 12 magazines. Okay, so now the probability of getting a leopard is 1 over 5. And now you consider 12 magazines more than 2 leopards. Means that now this is binomial. So X is binomial distributed. 12 magazines. The probability of getting the leopard is 1 over 5. And now he's getting more than 2 out of the 12 magazines. Right? So when more than 2, you need to count from 3 until 12. That means it's a lot of calculations. So I will just use a complementation rule, which is 1 minus px less equals to 2. Okay, 1 minus px less equals to 2. Because more than 2 means 3 onwards. So I minus the previous. That will be the same probability. So px less equals to 2 means that it will be px equals to 0 plus px equals to 1 plus px equals to 2. Okay, so for binomial distribution, the formula is x equals to b and p. Probability x equals to small x, it will be ncx px qn minus x. So by applying this formula, 1 minus 12c0. Okay, now the first one, when x equals to 0 means that there's no success. So when no success, you can just ignore first 2 terms because it will be 1. And then, on other words, it means all failures. So your p is 1 over 5. Right, p is 1 over 5. Then the q is going to be 4 over 5. So it means that all failures, 12 failures. Then px equals to 1 means out of 12, 1 success. That means 12c1, 1 over 5, degree 1, 4 over 5, degree 11. Plus px equals to 2 means that 12c2, 1 over 5, degree 2, 4 over 5, degree 10. Right, so from here, if you count all these together, it will be 1 minus 0.55835. We plus all these 3 probabilities together. So then it will be 0.44165. And now I round up to 3 significant figures. That will be 0.442. Okay, that's the probability of the parts B. Okay, now part C. Find the probability that after 5 weeks, Sahim has exactly 1 of each animal. So basically we have 5 animals. So after 5 weeks, he got 1 for each. Means that now, basically you have tiger, let's say T for tiger, L for leopard, R for rhinoceros, E elephant, B for buffalo. So I have T, tiger, L, R, E, B. Okay, these 5 animals. So after 5 weeks, means that exactly 5 weeks he got the animals already, each animals. Means that now the probability equals to, now each one is 1 over 5. Okay, here is 1 over 5. This is 1 over 5 because they have equal probability. It's mentioned in the question. So when you multiply all of them, it is same as degree 5 for 1 over 5. Now, but then we are not sure the order, the sequence of getting the animals. Right, means that we need to arrange these 5. So 1, 2, 3, 4, 5. Since these 5 are different animals, so then we have to multiply by 5 factorial. Because we are not sure which week is getting the T, which week is getting the L, and so on. Therefore, it can be in any sequence. Right? Therefore, this is the working for part C, and then you will be getting 24 over 625. Alright, so that's all for this part C. Okay, and it's also come to the end of the video. Alright, remember to subscribe to my channel if you enjoy watching my video, and stay tuned for more upcoming videos. Thank you. Bye.